Okay, YouTube, in this video we're going to use a technique that that we often employ when we're simplifying trigonometric expressions. But you'll notice that the expression I have here, 1 over 1 plus sine of x, is written as a fraction. And often when we simplify expressions, we don't like to deal with fractions. I think everybody can relate to that. So here's going to be our directive here. Write this expression so that it isn't in fractional form. Okay, so that is the goal of this video. I want to find a way to deal with something like this so that when I'm done with it, it's no longer written as a fraction, okay? And so the technique that we use, as a matter of fact, when you see something like this, 1 over 1 plus the sine of x, actually the technique that we use is to multiply by the conjugate of the denominator, okay? So that is going to be our method that we employ here. And the reason why is because, let's recall, in terms of conjugates, we say that given some binomial expression a plus b, then its conjugate is going to be that expression where we make opposite this middle sign here. We don't mess with the first thing, but we say if a plus b is our binomial expression, then its conjugate pair is a minus b. And the wonderful thing about multiplying two conjugate pairs together is we get a difference of two squares, this is what we're aiming for. This is what we want to have happen in this case, okay? So if you wanted to see the algebra behind this, by the way, that's a squared, it would be minus ab, and then we'd have b times a is a positive ab, and then we'd have minus b squared, where our middle two terms, of course, cancel out, and then we're left with this difference of squares. So in this particular instance, what we're going to do is we're going to multiply the top and the bottom, both the bottom and the top, by the conjugate of 1 plus the sine of x. So in this case, we would say that that would be 1 minus the sine of x. And the first thing that we need to recognize is this: when we multiply by 1 minus the sine of x, or 1 minus the sine of x, we're really multiplying by 1. Okay, and also this, I think that a lot of students are like, how did you end up with that on the bottom where I get 1 minus the sine squared of x? And you know what, I really do hate to show my work. I hate to do it. I'm not saying don't show your work. I'm just saying that I know how I got it. But if you really want to see how I got this here, okay, I took 1 times 1, I got 1. And say 1 times a negative sign would be a negative sine of x. A positive sign times a positive 1 is a positive sine of x. So there you go. Your middle terms are canceling out. And we say sine x times a negative sine x is a negative sine squared of x. So it is just to your benefit to know that 1 plus sine of x times 1 minus sine of x would, of course, arrive at, get us to a difference of squares where we get 1 squared minus sine squared. So we get an expression that looks like this guy right here, okay? And this is what we wanted to have happen. The reason why I wanted a diff of two squares, difference of two squares, is because when you talk about trigonometric expressions that are still algebraic, but trigonometric expressions that involve a square here, what this allows us to do is go borrow from our Pythagorean identities. Anytime you see a squared trig function, I want you to think in Pythagorean. So our primary Pythagorean identity is that the sine squared of an angle plus the cosine squared of an angle equals 1, as a matter of fact. And what that allows us to do, and has allowed us to do, is to manipulate it so that, for instance, if I were to put the sine squared on the right side of this identity, there's your 1 minus sine squared right there that I recognize from this expression, 1 minus sine squared of x. Well, 1 minus the sine squared of an angle would be equal to the cosine of that angle. Okay, so what I'm going to do is I'm actually going to take that 1 minus sine squared, I'm going to go replace it with a cosine squared. So here's what we end up with. This expression now dwindles down into this. We'd say, well, then what this really equals is 1 minus the sine of our angle. And this would be now over, instead of 1 minus sine squared, we could say that that's really a cosine squared of x using a Pythagorean substitution. Okay, so just like I mentioned in our last video, the reason why this is so beneficial to us here, and you notice we still have a fraction. I wanted to get this out of fraction form. But the idea is this: we have a monomial divisor. And recall that when you have a monomial divisor, it means that you can take all of the terms in the numerator, which we have 2 terms, and split them up over this denominator, which allows us to kind of arrive at this. We have 1 over the cosine squared of x, it's 1 over cosine squared, minus now sine to the first power, so sine x over cosine squared of x. So in terms of how am I going to get this out of fractional format, well, this thing right here, I recognize this 1 over cosine, that is the reciprocal, you guys. 1 over cosine is the reciprocal of secant. Okay, So 1 over cosine squared allows us to arrive at the fact that this would become a secant squared of x, and there goes the fraction there. Now this thing over here, I would love for this top thing to be a sine squared over a cosine squared, because sine over cosine is tangent, so sine squared over cosine squared, using our quotient identities here, would be a tangent squared. But the unfortunate fact is simply this. We have a sine to the first power over cosine squared. So I will show my work this time around. I will show it on this one. But recall that when you say cosine squared, you really mean cosine times itself. And what I'm going to attempt to do is show you what I'm doing here is I'm going to separate this 1 over cosine squared. I'm going to kind of throw it off on the side. So we have secant squared of x minus, now I'm going to take this individual sine of x, and I'm going to list it over just one of the cosines in the basement. So sine x over cosine x, that'll be a tangent x. And then we'll take that other cosine that was in the basement and we'll separate it off on the side, because I know that when I multiply two fractions, hey, we do it straight across anyways. So I'm really just kind of factoring this apart or separating it up and saying that now that I have this as sine x over cosine x, or 1 over cosine x, we can actually say that now we have this entire expression coming out as being secant squared of x minus now sine over cosine. We recognize that this is our quotient identity. This is a tangent of x right here. And then the reciprocal of cosine is just a secant of x. So at this point, I'm going to stop. We get to stop because we've accomplished our goal, which was to write the original expression such that it is no longer in fractional form. And this is a very common thing to do, which is multiply by the conjugate. Cheers.